Welcome to today's live stream on direct proportion, inverse proportion, ratio, and all these things to do with proportion, ratio, and graphs. And we're going to start off a bit direct proportion. And our first question we've got here is a nice, straightforward direct proportion question. It shouldn't take you too long. I'm only going to give you a minute to do it, because when you get good at this, you should be able to do it in a minute. Don't worry if you can't finish it. We'll go through it, and you can always attempt the second one so you can do it faster. Right, so here we go. We're told y is directly proportional to x for both a and b. Now, a lot of students get themselves confused by using the symbol proportion, y is directly proportional to x. I want you to just forget about that. And always, as soon as you see a direct proportion question, is think y is equal to a multiple of x, k times x. So always think, when you see direct proportion, y is equal to a multiple of x. Y is equal to a multiple of x, and always write it out like that, and then these questions become much easier to do. So you do 9 equals k times 3, because y is equal to 9 and x is equal to 3. So y equals a multiple of x, and we can see if k times 3 equals 9, then divide by 3, we can see k equals 3. So our equation, if the k value is equal to 3, is obviously y equals 3x. And once you've got the equation, it's quite easy to find our values. So if x is 9, 3 times 9 is 27, so y is 27. And here we've got y is 12, so write 12 equals 3x. Divide both sides by 3, we can see x equals 4. So you can see why this is only really a 1 minute question. So just remember, y is directly proportional to x, y equals a multiple of x. And if you have x squared or x cubed, then it's y equals a multiple of x squared or x cubed or square root of x. And just write that equation out, find your k, put it back in to get your equation. Okay, so really what I should have done was written, okay, y equals kx, so y equals 3x is my equation. And then you can do the rest of the question really, really easily. So here we go, next question. 60 seconds. See if you can get it done now. Oops, just seem to have lost the question. Let's get it back. Here we go, question's back again. Right, so we've got y equals 12 when x equals 3, and we're still directly proportional to x. So y still equals kx, put in the y, 12, put in the x, 2. So 2 times k equals 12, so therefore k must equal 6. So y equals 6x is our equation. X is 1, 1 times 6, y equals 6. Y is 42, so put 42 where the y is, equals 6x. So we can see divide by 6 that x equals 7. And there you go, direct proportion done. Right, here we have an inverse proportion question. Again, I'm just going to give you 60 questions, 60 seconds that is. Use your calculator if you struggle to do the mental arithmetic in that time, but it's more about doing the function, which is more important than necessarily doing the arithmetic. Obviously, when you're doing questions properly, you should always try and do them without a calculator. Right, so let's go. Now we're doing inverse proportion now. Now inverse proportion, if you were to write it using proportion symbols, means it's proportional to 1 over x. Now remember what I said in the previous one, that means if it's proportional to something, it means it's equal to a multiple of that. Now that's not a very nice way of writing this. We would normally write it, if you imagine k is just k over 1, and when you times fractions you get k times 1 is k, and 1 times x is x. So when doing these questions, what I suggest you do is you forget all of this and just plump and remember that if you have inverse proportion, y is equal to k over x. Okay, and if y is inversely proportional to anything, then it basically means it's k divided by what x to that function. So if you have y is inversely proportional to x squared, you have k over x squared. Now all those function ones come in the level 8-9 lesson, which I'll be live streaming tomorrow, and you can go and look on the video to do those. But let's just stick with the basic proportion questions here. So we know y equals 4 and x equals 3, so put 4 equals k over 3. Times this by 3, you get k. So times this by 3, that gives you 12. So k must equal 12. And that's what we put here. So we now have an equation. So when x is 4, 12 divided by 4 is just 3. Now we've got y equals 2. So when we're doing that, let's write y equals 2 and put 12 over x. Times both sides by x, we times this by x, we get 2x. Times this by x, we're left with 12. That is the way you should be thinking your algebra. I know a lot of students just think, oh, I'll just move that up there. But that's what's really going on. Now we divide by 2. So 12 divided by 2 is 6. And x equals 6. So let's have a go at another question and give you 60 seconds to try and do this one. Okay, so here we go. Remember, if we've got inverse proportion, this is an inverse proportion question, we know that y equals k over x. So we've got y equals 2 when x equals 4. So y equals 2 and x equals 4. To multiply those together, we get k equals 8. So y will equal 8 over x is our function. So now put x equals 2 into that. So 8 divided by 2 is just 4. Now write 10 into the equation. So let's put 10 equals 8 over x. Multiply throughout by x, so we get 10x equals 8. Divide by 10, we get x equals 8 over 10. So x therefore equals 0.8. Right, next we've got a little exam question on instantaneous rates of change. See if you can remember how you calculate instantaneous rates of change and have a go at this question. I'm going to give you a couple of minutes to think about this one. Right, here we have a little exam question on instantaneous and average rates of change. See if you can remember how you find instantaneous rates of change. On this last part, when you're looking for the average rate of change, same as the instantaneous rate of change, they're talking about the average over the whole time, and the point at where the instantaneous rate of change is the same as that. Anyway, here's 2 minutes to have a go at this. Right, let's have a little look at this question. So, we want to determine the instantaneous rate of change at 3 seconds, and that's where the gradient, okay, that is going to be the gradient is going to be the instantaneous rate of change at that point. And to find the gradient at that point, we need to find what the gradient of the tangent is at that point. So we need to draw a tangent. So if we draw a tangent up here and through here, we can see that it's going to go down. We work out our rate of change. So it's going to go down from 9, 8, 7, 6, 5. That's going to go down by 4, and it's going to go along by 4. So the gradient is going to equal minus 4 over 4, which equals minus 1. So the instantaneous rate of change is minus 1. And the way to get the units is rate of change is this axis divided by this axis. You've got meters over seconds divided by seconds, which is the same as basically having meters over seconds times by 1 over seconds. So you get meters over seconds squared. Okay, we might just think, if you know, you should know, if you divide a fraction by just a single thing, then it goes on the denominator here down at the bottom. Okay, so now let's just get a red pen so you can differentiate. Find the average rate of change for the whole graph. So our average rate of change, we draw a line from here to the origin, and we can see that it goes up by 4 and it goes 4 along. So the gradient will equal 4 over 4 for that line, and that gives us just 1. And that gives us our average. Average, we work out what is its velocity change between here and here, and that gives us 4, and then we can see that it took 4 seconds for that change. So our average change of velocity is going to be 4, and that's also going to be the same units divide the y-axis, because we're doing that distance divided by that distance. What time is the average rate of change the same as the instantaneous rate of change? Now this is not, I don't think, a very well worded question, because I was looking initially at the point where these would be the same, and there's no point where they're the same apart from maybe the origin here, when actually the gradient is equal to, if you draw a point and you draw a tangent where the average is equal to it. But actually what it wants is actually the instantaneous rate of change was equal to the average rate of change over the whole time, is what this question is looking for. So it's looking for when the instantaneous rate of change along here, it has a tangent that is parallel. And if we look, I think it's around about 2 seconds where we can create a parallel tangent. It's quite hard for me to demonstrate lots of different tangents, so I'll just draw one in at the right place, and you can see that at 2 seconds these are parallel. Okay, the tangent is parallel to this one, so it happens at 2 seconds. Right, here we go. We have an average rate of change question to finish off with here. It's quite straightforward. The numbers are nice. You don't need to give your answers to 2 decimal places, really. So I'm just going to give you a little minute, 1 minute to do this. That should be plenty to do this question. Off you go. Right, so let's have a look at that. We've got the average speed of car in the first half of the journey. So the journey is 50 kilometers. The first half is the first 25 kilometers, and we can see there's 1, 2, 3, 4, 5 divisions here, and it's about 2.5 divisions. So that's half an hour. So we're doing 25 kilometers. Okay. Divide by the time, which is half an hour, because we want the answer in kilometers per hour. So we want to measure this in hours, or you could use 0.5, it doesn't really matter. So 25 divided by either of those is equal to 50 kilometers per hour. What is the average speed of the car in the second half of the journey? So it's going to take half an hour to 2.5 hours. So this change here is 2 hours. And this change here is 25 kilometers. So we're doing 25 kilometers over 2. So that gives you 12.5 kilometers per hour. What's the average speed for the car over the whole journey? So over the whole journey, he's travelled, or the car has travelled 50 kilometers. and it has taken 2.5 hours. So therefore the average speed will equal 50 divided by 2.5. 2.5 to 5 is 2, and so we get the 20, so it's 20 kilometers per hour. If you found today's stuff a little bit straightforward, have a go at coming to the level 8, 9 stuff on these same topic areas tomorrow. Thank you very much.